One machine, 22.5 tons of finished steel. A 280 horsepower Mercedes-Benz engine. It grabs a full-grown tree, cuts it at the base, strips every single branch from the trunk, measures the stem, and bucks it to the exact log length the sawmill ordered. All in under 30 seconds, then swings straight to the next tree. No crew, no chainsaw crew. One operator in a glass cab. These are the 10 biggest, most powerful logging machines ever built, and every single number is real. Number 1. Ponsse Scorpion King. When professional foresters anywhere in the world say the words wheel harvester, the Ponsse Scorpion King is the first machine that appears in their mind. Built in Vieramäe, Finland by Ponsse Oij, a company founded in 1970 by a logger named Einari Vidgren, who believed he could build a better machine than anything on the market. The Scorpion King is the product of more than 5 decades of continuous refinement, and the specifications back every gram of the reputation. The engineering story of the Scorpion King is its 3-frame chassis. Virtually every other wheeled harvester on the market uses a 2-frame articulated design, a front frame and a rear frame joined at a single pivot point. The Scorpion King adds a 3rd central frame, and this is where the cab sits. This middle frame is hydraulically leveled at all times. The front and rear frames tilt freely with whatever terrain they encounter, but the cab and the operator inside remains perfectly horizontal. On steep side slopes that force other machines to stop completely, the Scorpion King keeps working. That design difference is not cosmetic. It translates directly into the number of operating hours per year the machine can log. Because it can work terrain competitors cannot. The Ponsse 50 parallel crane positions the boom directly above the cab rather than to the side. This overhead geometry gives the crane a full, unobstructed 360-degree working arc and simultaneously gives the operator unblocked sight lines in every direction. The double-circuit hydraulic system, the feature that earns the King designation, runs the crane and the harvester head on completely independent circuits. In practice, the operator can swing the boom toward the next tree at full speed while the H7 head is still processing the previous stem. 0 waiting between trees. Maximum production per hour. Number 2. John Deere 959 MH. In Scandinavia, wheeled harvesters dominate because the terrain is manageable and forest roads are well maintained. In North America, particularly in the old-growth and second-growth forests of British Columbia, Alberta, and the Pacific Northwest, trees are bigger, terrain is steeper, and the operating conditions are harsher. Here, tracked harvesters are the preferred tool, and at the top of John Deere's tracked harvester lineup sits the 959 MH. The 27,200 kilogram operating weight of the 959 MH tells you immediately what environment it was designed for. This is not a precision forest thinning machine. It is a high-production, clear-cut harvester built to process large-diameter softwood on terrain that would be completely impossible for a wheeled machine. Western hemlock and Douglas fir in coastal British Columbia routinely reach 80 to 100 centimeters in diameter, and a well-configured 959 MH running a compatible large-diameter harvester head can maintain production rates in these conditions that no European wheeled machine can match. John Deere Intelligent Boom Control System, standard on the 959 MH, uses sensors throughout the boom linkage to automatically optimize the swing path between trees. Instead of the operator manually managing each joint of the crane independently, which takes years of skill to do efficiently, the IBC system computes the optimal trajectory and executes it with a single joystick input. Studies conducted by John Deere show IBC reduces operator fatigue significantly over a full shift and maintains production consistency in the final hours of a shift that would otherwise decline as the operator tires. Number 3. Komatsu 895 Forwarder. The harvester processes the trees, but those logs are worthless until they reach the road where trucks can collect them. That transportation job belongs to the forwarder, and for maximum payload operations, the machine the industry consistently reaches for is the Komatsu 895. Everything about this machine was engineered around a single mission: carry 20,000 kilograms of logs across soft, uneven forest terrain without destroying the forest floor, the road, or itself. Take a moment with those numbers. An empty Komatsu 895 already weighs 23,600 kilograms, loaded to capacity with 20 tons of freshly cut logs, and the total rolling weight climbs to approximately 43,600 kilograms. That is heavier than a fully loaded articulated dump truck. The reason this machine does not leave catastrophic ruts through the forest floor is its 8-wheel bogie axle architecture. Each rear bogie pair can flex independently over obstacles, spreading the machine's enormous weight across a far wider tire footprint than any standard 4-wheeled vehicle at comparable load. In wet conditions on soft soils, this ground pressure distribution is the difference between sustainable forestry and permanent site damage. In 2024, Komatsu announced the 898, a direct evolution of the 895 platform designed around a 25,000 kilogram payload, the largest load capacity ever offered on a production forwarder for commercial sale. The 898 uses 30.5-inch wide rim rear wheels, an upgraded hydrostatic transmission with dual hydraulic motors on each bogie axle, and a maximum tractive force of 345 kilonewtons on the 8-wheel drive version. The crane fitted to the 898 reaches 205 kilonewton-meters, lifting torque as standard. It is the new ceiling of forwarder engineering, built for the largest clear-cut operations in Scandinavia and the Baltic states. Number 4. Tigercat X870D. In North America, particularly in the vast pine plantations of the southeastern United States and in the boreal forests of Canada, whole tree harvesting remains the dominant system. Feller bunchers, machines that fell trees and accumulate them in piles without processing, are the production engine of these operations. And the current benchmark for high-cycle feller bunching is the Tigercat X870D, built in Brantford, Ontario. The defining competitive advantage of the X870D is Tigercat's extended reach boom technology. In a conventional feller buncher boom, extension and retraction travel through a single-cylinder arrangement. In the ER system, a more sophisticated 2-cylinder linkage allows the boom to extend and retract on a near-horizontal plane, dramatically expanding the working envelope without requiring a full upper structure swing for every reach. In a dense plantation where trees are spaced 2.4 meters apart, and an operator is cycling through them at the rate of 1 every 25 to 35 seconds, this reduced swing angle per cycle accumulates into a significant production advantage over a full shift. The closed-loop hydrostatic track drive on the X870D delivers maximum tractive effort at any travel speed, whether the machine is moving at top speed, repositioning between bunches, or creeping at minimum speed through tight timber without damaging residual trees. The 330 horsepower FPTC-87 engine provides the sustained hydraulic output needed to keep both the saw system and the boom moving simultaneously without any perceptible power drop. In high-volume flatland pine operations, a properly set-up X870D operator can fell and accumulate 70 to 80 trees per productive hour. Number 5. Tigercat LX870D. The X870D is built for flat and moderate terrain. But logging does not stop where gentle ground ends. Some of the highest value timber on the continent grows on terrain so steep that a conventional feller buncher would roll down the hillside before it ever reached a tree. The Tigercat LX870D is the answer to that problem. The word leveling in the LX870D designation describes the most critical engineering feature on the machine. The Super Duty leveling base allows the entire upper structure, the cab, the boom, the slew ring, to tilt relative to the undercarriage by a large angular range in both directions. As the machine traverses a steep side hill, a hydraulic leveling system continuously monitors the angle and adjusts the upper structure tilt to keep the boom, the operator, and the center of gravity correctly positioned. Without this system, the physics of a 40,000 kilogram machine on a 40-degree slope are simply unworkable. The R7-163L track frames, 330 mm longer than the frames on previous generation Tigercat leveling machines, were a direct response to operator and contractor feedback about downhill stability. When a loaded accumulator head is hanging off the boom on a steep downslope cut, the moment force trying to pull the front of the machine downhill is enormous. The extended track contact patch resists that force. Combined with a cable assist tether anchored to an anchor machine at the top of the slope, the LX870D can work on gradients that would be completely inaccessible to any non-tethered machine. Number 6. Tigercat X870D. In whole tree harvesting systems, the feller buncher drops the trees. Then a skidder has to drag those bundles from the cut block to the landing where a processor or loader is waiting. Skidders take more daily abuse than almost any machine in forestry. Constant loading, constant wheel spin, constant impacts from logs and stumps. And the Tigercat X870D is built to absorb all of it, while delivering the highest payload capacity in its class. The 6-wheel configuration is the central engineering argument for choosing the X870D over any 4-wheeled competitor. By adding the WOB-17 widespread rear bogie, which carries 4 wheels in 2 tandem pairs that can flex independently over obstacles, the X870D distributes its loaded weight over 6 contact patches instead of 4. This does 3 things simultaneously. It reduces ground pressure in soft terrain, improving traction and reducing ruts. It improves the machine's ability to drive over large obstacles like stumps and slash piles without losing traction on the driven wheels. And it dramatically reduces the likelihood of getting stuck in the worst conditions: deep mud, snow, decomposing wood debris that flatland pine operations regularly produce. The turnaround 220-seat is a genuine operational innovation. A skidder operator spends most of the working shift looking backward, watching the grapple and the log bundle as the machine backs into position and drags the load to the landing. In a conventional skidder, the operator twists in the seat to look back, which creates cumulative physical strain over a 10-hour shift and reduces the precision of machine control. The X870D seat rotates 220 degrees with a single button push. The operator faces the direction of work. The controls, steering, drive, grapple, are all positioned correctly for the rotated position. After 10 hours of continuous operation, the X870D operator is more alert, less fatigued, and making fewer handling errors than a comparable operator in a non-rotating machine. Number 7. Tigercat LX877. The LX870D handles most steep slope applications. But in the coastal old-growth and second-growth forests of British Columbia, Washington, and Oregon, where trees can reach 150 centimeters in diameter and slopes regularly exceed 40 degrees, even the LX870D is working at the edge of its capacity. The Tigercat LX877 was built for exactly these conditions. It is the most powerful leveling feller buncher Tigercat currently manufactures. At 350 horsepower, the LX877 produces 20 more horsepower than the LX870D. That gap might seem modest on paper. In the field, on a 45-degree slope with a large diameter accumulator head loaded with coastal timber, the difference is absolute. The leveling cylinders, the slew ring swing motors, and the ER boom cylinders are all under simultaneous load when the machine is felling large trees on extreme terrain. The 350 horsepower engine ensures that every one of those hydraulic circuits receives full flow and pressure simultaneously, with zero compromise between functions. In a 260 kilowatt machine, pushing all circuits at once would cause visible hesitation and pressure drop. In the LX877, it does not. The through-tip hose routing on the LX877 boom is a detail that only slope operators will fully appreciate. On steep terrain, hydraulic hoses routed along the outside of the boom are constantly flexing, twisting, and contacting rocks, stumps, and standing trees. This leads to hose failures that on flat ground are an inconvenience. But on a 45-degree slope with a tether cable attached, a hydraulic failure is a serious safety event. Routing the hoses through the boom structure itself protects them entirely from external contact and dramatically extends their service life in the harshest operating conditions on the continent. Number 8. John Deere 1910G forwarder. The Komatsu 895 is the payload king, but not every operation needs 20 tons of carrying capacity. For contractors who need a balance of high payload, advanced technology integration, terrain capability, and North American dealer support network, the John Deere 1910G has become the benchmark forwarder, and in terms of raw capability, it is anything but a compromise machine. The John Deere Duraxle rear bogie is a component that does not get enough attention in discussions of what makes the 1910G exceptional. Forwarder rear bogies carry the majority of the payload load. Typically 70 to 75% of the log weight sits over the rear axle group when the bunk is fully loaded. The Duraxle was designed from scratch for sustained maximum payload extraction across multiple shifts per day. With larger bearing specifications, heavier pin sizes, and a thicker bogie frame cross-section than the axle systems used on lower specification forwarders, the result is a machine that delivers 19,000 kilogram payloads day after day without accelerated bogie wear. Timbermatic Maps is where the 1910G pulls completely away from the competition on the technology side. When a harvester and forwarder are operating together in the same cut block, which is the standard cut-to-length system, both machines share a live digital harvest map. The harvester uploads stem data as each tree is processed: GPS location, species, diameter, length, volume by assortment. The 1910G operator can see exactly where every pile of logs is located on the map, what species and sort each pile contains, how much volume is waiting at each location, and the optimal travel path through the block to collect maximum volume per trip with minimum soil disturbance. At end of shift, the entire data set uploads automatically to the forest company's inventory system. No tally sheets, no radio calls, complete digital chain of custody. Number 9. John Deere 959 MH processor configuration. The 959MH appears on this list twice because it is genuinely versatile enough to warrant it. In its harvester configuration, it operates in the forest processing standing trees. In its processor configuration, fitted with a large diameter processing head and positioned at a landing, it becomes the most productive whole tree processing machine available in North America. In whole tree harvesting systems operating in the U.S. South and Eastern Canada and in parts of the Pacific Northwest, feller bunchers drop the trees and skidders deliver whole trees to a central landing with branches and tops still attached. Something has to process those trees into clean logs before the trucks can load them. A 959MH in processor configuration, running a Waratah HTH623C or similar large diameter head, can keep pace with the output of two high-production feller buncher and skidder teams simultaneously, processing 60 or more stems per hour in large diameter timber without mechanical hesitation. The combination of the 959MH carrier and the HTH623C head at a landing creates a processing system that operates with a precision that is genuinely difficult to comprehend until you stand next to it. A full-length coastal cedar arrives from the skidder, 25 meters long, 65 centimeters at the base. The head clamps, the feed rollers engage, and the stem begins moving. The computer reads the diameter at the sensor point 30 times per second. As the measured diameter matches the program specification for a particular log sort, the saw fires instantly. The cut log drops. The head keeps feeding. The entire tree base log, mid-log, top section is processed to exact lengths in under 45 seconds. No chainsaw, no manual measure, zero variance from the programmed specification. Number 10. North American off-highway log trucks. 9 machines that harvest, process, and move timber through the forest. But all of that production means nothing until the logs reach the highway and the mills. The final machine in this list is not a single model. It is a category of vehicle that represents the absolute limit of what road engineering and regulatory frameworks allow. The North American off-highway log truck In British Columbia, Canada, one of the highest volume timber-producing regions on Earth, trucks operating exclusively on private Forest Service roads are exempt from public highway gross vehicle weight regulations. The manufacturers of choice are the Western Star 4900 series, Kenworth T880, and Peterbilt 367, all North American heavy-haul truck platforms fitted with purpose-built reinforced frames, multi-axle trailer systems, and sometimes self-loading knuckle-boom cranes mounted directly on the truck frame. An off-highway log truck operating on a private British Columbia forest road with a gross vehicle weight exceeding 80,000 kilograms is carrying more weight than 12 fully loaded Ford F-350 pickup trucks stacked on top of each other. The road infrastructure required to support this engineered fills, rock-surfaced running surfaces, carefully designed grades, represents an enormous investment that logging companies maintain privately throughout their tenure areas. In Nordic countries, the equivalent vehicles operate under Finland's progressive long vehicle legislation, which permits road trains of up to 76 tons gross vehicle weight and 34.5 meters total length under specific permit conditions. In winter, when the frozen ground can support dramatically higher axle loads without deformation, these Nordic log trains carry volumes that would be completely impossible on the same roads in summer. The machine is the same. The ground beneath it changes the entire operating equation. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.